All right, welcome to another episode of The Monk and the Hedonist. Today we have an exciting episode and a special guest, Dr. Drew Taylor. Um, Drew, what are you drinking today?
Nothing more than some high quality H2O.
H2O. There's nothing wrong with that. I'm actually in clinic, so I could not be the hedonist today. I'm drinking green tea, so don't feel bad. Um, for the audience today, we're going to be talking about a really exciting topic that has just a ton of future potential. We're going to be talking about stem cells. And Drew is based out in Toronto, and he is the CEO of a company called Acorn Biolabs. And that it's a company that has figured out a way to do a non-invasive way to preserve your stem cells by the means of your hair follicles. So it's a really fascinating concept. In full disclosure, I am an investor in Acorn because I see the potential in it. But really, I want to spend the beginning of this episode just talking about stem cells in general, just so that we can introduce the science of stem cells to our audience. So, Drew, if you don't mind, maybe just talk about your background and how you got into the stem cell field.
Absolutely. Well, first of all, thank you so much for having me on. Excited to be here. My background was in the healthcare side, kind of the whole way through. I ended up getting introduced into healthcare pretty early on. My father was a physician, and I was always drawn to medicine. And I actually ended up really kind of solidifying my passion for, one day going into healthcare back in grade 7 with a science project. We had to actually create a science project that broke down something mechanical and explain how it works and how it's used today and all of those different things. And so I ended up being the only person in the class, in the grade, that chose a total knee arthroplasty. There was not a lot of competition for that subject. A few people wanted the guitar and other things, but I went for a total knee arthroplasty. And so I ended up, back then, probably rules have changed a little bit today, but I was able to actually go into the theater and witness that surgery myself. And so from that moment, being involved in seeing that entire team come together to execute on that surgery and provide this benefit for the young woman, I was fixated on healthcare as a profession, and actually was planning on going down the path of being an orthopedic surgeon. One of them had a huge impact on me, and they actually explained to me how these prosthetics that we implant break down over time. And so I ended up, kind of really thinking about that and taking that to heart. And one of the things that he drew my attention to is that instead of metals and plastics, in these implants in the future, it'll be our own cells that we're giving back to the patient, using our own tissues to recreate those tissues. And so that always stuck with me. So I followed that path, and I went down to the University of Michigan, did a undergraduate there in biology and a master's in molecular cell developmental biology, and was going to head off to medical school. But I had a unique opportunity to play professional baseball. So I figured I could go back to medical school one day, but I only had one shot at seeing how far I could take baseball. They wouldn't let me do the MD at the same time. I did give it a shot, but they turned me down. But they would let me do a PhD. And I'll forever be grateful for that push into the research side, because it really invigorated my passion for bringing, stem cell applications from bench to bedside. And so I ended up getting involved at University of Toronto, did a Ph.D. in Biomedical Engineering in the off seasons, was going back and forth, and specialized in regenerative medicine, stem cell biology.
What an impressive background. Going from baseball to really hardcore science.
It was a good thing I did the science, because baseball didn't pan out for that long.
Right. So what drove you into the whole stem cell field in particular?
Yeah, I think it was the idea that we all within us have these amazing cells that reside in pretty much every tissue in our bodies that act as kind of a wellspring to really provide, rejuvenation and regeneration of those tissues. And the idea of, if we are able to harness those cells and preserve those cells in a way that they can continue to deliver that benefit that unfortunately they lose the capacity to deliver on as we age, we could really fight not just aging, but all of the associated diseases along with aging.
Yeah, and the time of, I guess, when some stem cells are extracted from your body matters, right? I mean, someone who's getting it when they're 80 versus 30, it makes a huge difference in the quality of those stem cells. Why is that?
Well, I think it's a very long list of reasons. What's happening inside our stem cells is the same thing that's happening in the rest of our bodies, really. They definitely have an ability to self-renew, but they are still being exposed to erosion of telomeres, DNA mutations, and all of these unfortunate, terrible things that accumulate with age. Studies have shown that the amount of DNA mutations that we experience double in our bodies every decade that we live. So this is an exponential effect that continues to accumulate. But I think ultimately, for those cells specifically, we depend on them so much for the regeneration and the maintenance, really, of the tissues. When they fail, it's only a matter of time before our systems start to unfortunately go downhill.
Yeah, my father my father was diagnosed a couple of years ago with a neuroinflammatory spinal condition called arachnoiditis. Very rare.
Mm-hmm.
And not much treatment for it. And one of the therapies that was recommended as experimental was stem cells. So he had adipose derived stem cells. Of course, he was 75 at the time they were done, and that was what he was told. Obviously, that a 75-year-old stem cells, it's questionable how effective this is going to be. Compared to if he had it done when he was 40, let's say.
Right.
But regardless, the pain he was having has significantly gone down since that stem cell procedure. So that it definitely made me very curious about the whole field after that, after seeing him go through that.
Yeah. Well, you said a few key words there, right? One of them was experimental, because I think that's unfortunately the phase of the existence of these opportunities in stem cell treatments and medicines that we're in right now. But it's accelerating very quickly. And I think in instances where stem cell therapies are being delivered in a safe way, we are seeing the first indications really recently, in the past number of years, of the true potential, right, of the cells that reside within us, even for people that unfortunately are getting older. I think that we're going to start to see limitations, right? There already have been limitations that have been set for a number of treatments that would be stem cell treatments, especially around bone marrow, of where we see vastly diminished effects, especially over the age of 65, and benefit that ends up getting conferred. I'm really glad to hear that your dad had a great experience, even despite being 75. But we do see these massive drop-offs, and one of the reasons is just the amount of adult stem cells that we have in our bodies. I don't think this is news to anyone, but it peaks in our 20s, right? That is the prime of life, and then it begins this very slow arithmetic decline, and that continues until sometime in our 60s, usually around 65, and we see that really pick up pace. That decline all of a sudden accelerates, and obviously it depends on the individual and their personal health and the choices they made, but that drop-off is coming at some point, and usually on average it's in the 60s.
So where are we today? You mentioned that there's been some pretty phenomenal results that we've gotten from stem cells on various different medical applications. Can you talk about some of those?
Yeah, for sure. So I think it's important to first of all define a little bit about what a stem cell is, and not to take it too high level, but with any kind of excitement around a word or a new thing, there tends to be a lot of information that ends up coming out and a lot of different people talking about it. And I think it's important because we end up seeing these snippets of stem cells did this and stem cells did that. And it's very important to understand that there are many different types of stem cells out there. And I kind of like to describe cells in general in our entire bodies as more like a mountain, right? And that magic moment when sperm meets egg and the cell can become anything in the body is at the very peak, the top of that mountain. Around the base of that mountain, the ring of the floor ground level, is cells that have become what they're supposed to be in our bodies: a skin cell, a liver cell, kidney cell, whatever that is. And so that stem cell has the opportunity to roll down one of those sides of the mountain, and it follows a path to create that end cell type that is serving a purpose or executing on a mission inside our bodies. And at certain points down that mountain, we see different types of stem cells that we've defined, because they still have the ability to become multiple types of cells. Only that cell at the very top of the mountain can become anything. But we have other stem cells that are halfway up that mountain, and they can become anything on that face, that side of the mountain, right? So most of the therapies that we're targeting today are in those stem cells that are, a little bit of the way up the mountain, but not all the way up. And there's very good reason for that, right? We can access them in our bodies because we have these pools of these stem cells. And like in your father's example, there are stem cells in our fat tissue, in our adipocytes. And they are, part of the mesenchymal lineage, right? So very closely associated with bone and cartilage. And so these cell types have the ability to provide benefit in those areas, right? Which is exciting. And then we also see stem cell populations that exist, right, in other areas of our bodies. And one area that we've decided to really focus in is the adult stem cells that are located in our hair follicles. And that's because they're very diverse, very plentiful. It is this kind of reservoir of adult stem cells, but, excitedly, it's accessible. Very different from, having liposuction surgery to harvest adipocytes or drill into your iliac crest to harvest bone marrow. We're just plucking follicles from the back of your scalp, non-invasively. And so that's very exciting. And I think that that's where we see the talk of these different types of stem cells. What has emerged recently, just as the last kind of thing, is the ability to reprogram cells. And so this is leading to an extremely bright future and a tremendous amount of excitement. And the initial discovery of the ability to do this has actually already won the Nobel Prize. It was actually the fastest turnaround time between discovery and awarding of a Nobel Prize in any category in history. And that's because this group, Yamanaka and others in Japan, ended up creating a pluripotent stem cell, like that magic moment when sperm meets egg, out of a skin cell. And so they were able to take a skin cell and push it back all the way up to the top of the mountain and behave like that magic moment, right, where that cell can become anything. And so this leads to immense possibilities of literally taking skin cells from the hair follicle or a biopsy and being able to create liver cells, kidney cells, pancreas cells, you name it, on demand. And so that is where there is a very bright future. Now, that reprogramming technology is, it is what it is. We're reprogramming those cells. And so it leads to a lot of questions on safety and things that, we need to make sure that the studies are designed correctly. And as therapies start to become, experimented on in trials with humans, we need to make sure those are designed extremely well and thinking of the patient's safety first. But that being said, using your own cells, your autologous cells, has become a very exciting space in a number of different areas, especially in aesthetics and sports medicine, for us to capture and really use our own adult stem cell populations in our body today.
And what applications are, because we talk about potential in the future for stem cells, and I think that makes sense to a lot of people. What applications are being used right now that are working?
Yeah. So I have to be careful here because I think that right now it's very difficult to work in the world of stem cells in North America, right? So, and for very good reason, Health Canada and the FDA have very strict guidelines on what we're able to do with stem cells to try to deliver benefits to patients. And that is to protect the patient, because a lot of these things are still experimental. as you said, and ultimately, patients need to be aware, like hyper aware to what is happening. And unfortunately, I think the world of stem cells, because it is exciting, because it has so much potential and it can benefit patients, there are groups that are operating in the stem cell space that I would say are not totally thinking about patients' interests first, and they're capitalizing on an exciting space. So not everybody that is offering stem cell treatments are doing so with pure patient health intentions. And a number of these groups are operating outside of the FDA and in other countries, right? And so medical tourism has become a bit of a thing to some of these areas. Not all of them are operating with ill intent, and some of them are delivering massive benefit to patients, outside of FDA guidelines. But patients have testified to massive improvements. So it is exciting. But it's a bit of a gray space right now, right? And it's very difficult even for a physician to understand a group that's not operating in the U.S. on whether they're doing so safely. And look, at some of these groups are operating right here in the U.S. or Canada as well, right? So you don't have to really travel to find them. So I think it is one of those spaces that's still finding itself, right? Because of the massive benefit that can go to patients, there is a little bit of gray zone. But we see stem cells right now in a number of different areas being applied to things like skin care, regeneration of skin, treating diabetic foot ulcer, wound healing management. And these are some that are operating within clinical trials that are being properly operated and delivering patient benefit today. Right, you have to enter that trial. It is an experimental treatment, but I've seen firsthand the benefit that can deliver to patients, especially in a large trial of that nature that happened up here in Canada for treating burn victims, all from a biopsy of their skin cells, regrowing patients' sheets of skin, right? So these adult stem cells that reside in these populations can be very powerful and deliver a lot of patient benefit, but we're still in the infancy of this as being available in every hospital and every physician having an opportunity to help you get to the stem cell therapy you need. We're not quite there yet.
Yeah, thanks for that explanation. Because you're always seeing reports now in the news of lawsuits for clinics who have been using stem cells occasionally in an inappropriate way. I think it's confusing for patients and consumers as to who do you trust when you see that kind of stuff. Certainly there is potential for stem cells. However, it seems like the applications for it currently are a little bit nebulous as far as what's evidence based. What is working and what's not.
I think one of the biggest indicators and the biggest advice that I can see is if groups are actively working alongside academic partners or publishing, that's a very good indication, right? That's not a perfect one, but it's a very good indication that there is a lot of upfront work being done because of that shared information with an academic partner or a research collaborator that is in academia, right? So those things I think are very powerful, and that's how we've tried to position ourselves.
Yeah, that's a great point. Yeah, can you talk about one or two studies that you know of that are going on in academic centers with stem cells?
Yeah, I can talk about some of the ones that we're running if you want.
Perfect. I love that. Yeah.
So we've got a few active modules of leveraging a patient's own cells. And so just to kind of recap, at Acorn, we offer the ability right now to bank your cells. And the reason we do that is because, unfortunately, as we age, the amount of stem cells, adult stem cells that we have, and the quality of those cells is diminishing rapidly. And so we are in a race against time. And unfortunately, most young people don't need stem cell treatments, right? And so we see things most likely later in life when our cells are at their worst. And so making sure that patients have access to their best cells to use in these autologous cell therapies is essential to make sure that we can actually deliver them the benefit they need. I saw that firsthand when I was working at Mount Sinai in the bioskeletal tissue engineering team in the Department of Orthopedics. Our goal was to recreate cartilage. And we saw firsthand age and the onset of disease like osteoarthritis were the two indications that really limited our ability to recreate cartilage on demand in the lab. So early on in my career, this was hit home, right? The exact moment we're going to try to help patients, unfortunately, we're going to be having to tell them that, you know, your cells don't have enough high quality or are not an appropriate resource for us to deliver the benefits, so you're not eligible for the therapy. And so that is the future that Acorn is preventing, right? Now, as far as some of the work that we're doing, so once those cells have been banked, they're now a resource for that patient, really for the rest of their lives, right? And they can call upon that, withdraw cells to use as the starting material in future therapeutics. And so we're working on a few different areas. One of the ones that is, I would say, the closest or the nearest term is actually using the cells that a patient has banked, those adult stem cells, to recreate and to grow the things that we need for healthy skin and healthy hair. And so the building blocks of our skin and hair, things like collagens, elastin, hyaluronic acid, all of these growth factors that are essential for skin health, we can actually have those cells create those things on demand. And so essentially we're creating a solution, right, similar to how we spin down blood and extract PRP, except it's actually from the very cells that are responsible for keeping our skin healthy, right? It's not an ultrafiltrate of general growth factors. It's the specific building blocks of our skin and the specific growth factors we find in skin. So it's a very much more targeted approach, and we're very excited about it. And so we are working through the ability to actually deliver that at a scale so that, patients can be taking their banked cells and recreating, essentially a solution for rejuvenation and healing of skin, as well as regrowth of hair. And so that can be administered topically or injected, but does not contain live cells itself. So therefore, much better safety profiles from a requirement of some of the long-term clinical trials and when you're dealing with live cell therapeutics.
How far do you think we are from using a product like that?
That's a tough question. I don't like making promises, but I am excited about the pace of the work that's been going on. We've got such a fantastic team, and they're working night and day to try to bring this to reality. And so we've already started the initial planning of first inpatient. So I do think that it is within the next, calendar year that we're going to start to see us submit the first trials to run that through patients. And again, that would be an aesthetic therapy. So we'd be rejuvenating skin and regrowing hair with that. And we have some physician partners that are pretty eager to help us start with the first waves of patient access. So that could be very exciting. A little bit longer term, right? But pretty close behind. PRP is also a very popular therapy in sports medicine. And so we are thinking about then translating some of that work into other types of connective tissues, right? So skin is, the fibroblasts and keratinocytes, they are types of connective tissues that can translate very well to other tissues that are high in requirement of collagen as a structure. So tendons, ligaments, right? All the sprains that we experience during athletic activity. So sports medicine is a big area as well. And then we have a number of long-term trials that we're running with, like projects with academic groups. And so we're working with Mount Sinai Hospital here in Toronto, University of Toronto as well, and Ottawa University. And these groups, we are thinking about those technologies that I described before about reprogramming the cells. And so those long-term projects that we're engaged with these academic groups is taking our hair follicles, right? They can be harvested non-invasively from patients and banked long-term, pulling out those samples from cryogenics, multiplying those cells, reprogramming those cells, and then tuning them to the cell types that we would need for therapies. And so right now we have already, in our joint project with Sinai, turned our hair follicle samples into induced pluripotent stem cell lines, and then pushed those cells into precursor pancreas cells. And we're working on continuing to push them into beta islet cells for reasons of tackling things like diabetes, right? So some very ambitious long-term studies that are not going to be available within the next year, right? These are long-term projects where we're still working out some of the basic elements before we'd ever conceive about putting these into patients. But some of the other projects with National Research Council involved turning the hair follicles into neurons and blood-brain barrier cells. And then we have a really interesting project that is in its infancy with the University of Ottawa, where we're looking at mechanisms to analyze the efficiencies of reprogramming. And so this is important when you do this at scale for patients. So we're really thinking about the future of being able to have like patient access for this, right? This is not a one-off thing that, you know, for a press release. This is like, we want to be able to figure out ways to further widespread access. And so one of the important things is finding simple solutions to make sure that the process of reprogramming these cells was done correctly, efficiently, and you have a product at the end that can be validated. So we're working on some projects around that with them.
So with the ability to reprogram cells, if you look at a hair follicle that's from a 40-year-old versus a 70-year-old, if you're reprogramming those cells, does age still matter at that point?
It does, yes. Short answer is that it does. We do see some heterogeneous, right? So mixed response, elongation of telomeres, for example, and resetting of the epigenetic age, right, with reprogramming. But by no means is it complete, and it is very sporadic in nature, and you end up getting this heterogeneous population of a wide range of mix. I think that we're going to continue to improve upon that, right? And I'm really excited about that, because I think that the better we get at that, the more complementary it is towards what we're doing. And I think that the two things are extremely synergistic. Reprogramming the cells does not, reset damage that's accumulated.
Okay.
It doesn't reset genetic mutations that have happened, right? So, even if you solve one aspect of aging, there's a number of others, like, very popular in the longevity community right now. We talk about the hallmarks of aging, right? There's a number of different elements that need to be solved to reset aging or to reverse aging even slightly. And of course, I think that what we see in the future is that all of these different technologies coming together to provide solutions for patients. And I think that to deliver on that future that we all envision, we're going to have to see successes in all of these areas.
Mm-hmm. Mm-hmm. I love the example of the mountain that you used, and depending on where the stem cell is sitting on that mountain can dictate what the end result's going to be, right? The end organ function. So where, if you took a stem cell from a hair follicle, where does it sit on that mountain?
Yeah, so it's one of the amazing things about the hair follicle is it's a very diverse population. And just off the top, the higher up the mountain doesn't mean the better, right? Sometimes it means the higher up the mountain, the more the risk, right? So if you have a cell from the very top of that mountain, right, and you put that into your liver, this is part of the danger, right? What if it becomes tooth enamel? It has the ability to become everything. What if it becomes something somewhere where it's not supposed to be?
Yeah, you can get these tumors, right? These teratomas.
Exactly. These teratomas, right? Which is the immense risk. So having the right cell for the job is what's important. Being able to reset and reprogram it just gives us a blank slate that we then need to make sure that cell gets to the point of that it is the right cell type for the job. Mm-hmm. So a hair follicle is amazing. I honestly feel like the hair follicle was made for regenerative medicine, right? It feels that way anyway. It's very accessible, so you can extract it easily. And this mini organelle, this tight bunch of cells, and my wife loves the word organelle. It was new to her, so she just doesn't like me using it at the dinner table. So this mini organelle has multiple germ layers, right? So we've got like the surface layers of our skin, right, in the ectoderm, right, the keratinocytes. Then we also have the deeper layer, the fibroblasts, right? And inside the hair follicle itself, there's even a diverse population of stem cells. You have stem cells that are akin to the ectodermal layer, and also stem cells that are mesenchymal stem cells. So you end up having a very diverse population. One of the exciting things that we've done with our group is be able to tune the culture media, how we grow those cells, to select better for the cell types so that you can even get populations of specific ones. Because again, you want the right cell for the job, right? And so that's part of it.
Right.
So I think that the hair follicle is also exciting because one of the biggest issues that has come up with things like umbilical cord, right, is it has a lot of potential, and obviously, it has been used to treat childhood leukemia and other things, but unfortunately, we can't expand those cells very well, right? That's been a big challenge. And so having enough cells has been an issue. And that's actually why the FDA said over the age of 18, it's no longer appropriate. It's because of cell volume, right? It doesn't mean those cells don't expire. Once they're frozen in liquid nitrogen, theoretically, they'll last thousands of years. It's more that we don't have enough cells to treat a full adult body. And so one of the things we love about keratinocytes and fibroblasts is that they are very good at expanding. And so you can passage these cells and make fold expansions, more of them from what you started with. And then you can reprogram, a population of those cells to then be that blank slate, that template to go any direction. So those qualities of the hair follicle are equally exciting. The primary cells to use within them and the adult stem cells that are already present, and its unique ability to be very easily expanded and reprogrammed.
So people who use, like, let's say, bone marrow or adipose stem cells, they may throw in a controversy about hair follicles, right? I've seen people who are kind of believers in one way
Of course.
of doing it, not be believers in other ways, right? So can you just go over some of those arguments for the general population so they understand?
Yeah, I mean, I think the arguments are more based on if you're effectively helping patients and delivering value to them in an area and making money on it, you're going to be very defensive about that area. I think in reality, ultimately, there has been a lot of benefit that is derived from delivering adipocytes to patients. They are still adult stem cells. They may be fat cells, but they're still adult stem cells. And there still are generic growth factors that are present in most all of our adult stem cells of different various kinds that are produced by those cells. And in the same way as we look at PRP and are able to fractionate blood and isolate and concentrate growth factors in our blood to deliver benefit to a patient in a specific area, doing so with stem cells can provide benefit. Can bring risks, obviously, but in cases where it's done right, it can deliver benefit, even if you're trying to deliver benefit, for instance, as I've seen many times, to sports injuries and skin, or even hair regrowth using adipocytes. They are still producing positive growth factors. Unfortunately, it's still not a perfect match, right? If you're trying to heal skin, you're taking some of the good elements that fat does produce that are generalist, beneficiary molecules, but you're not precisely taking the ones from your skin that are for your skin.
Right.
So there are specific growth factors on top of those general ones that we see in adipocytes and PRP that are not present in those areas, that are only present in skin and are produced by skin cells in higher volumes because that's their purpose, right? Their purpose is to regenerate our skin. In fact, the cells that are responsible for wound healing, majority of the adult stem cells actually reside in our hair follicles locally by that wound and migrate out of our hair follicles to help that wound heal, right?
Yeah.
So they have these pools of these cells that are perfect for skin health, regeneration, rejuvenation, and even hair regrowth as well. They are from the follicle. So it's more getting straight to the point. I'm not saying one's bad. I'm just saying one might be better.
Yeah. So currently, bone marrow is probably the most. Would you say that's the most commonly used?
Historically, yes.
Yes.
Right? I think there's been quite a resurgence in fat. And fat's very interesting, especially in aesthetic medicine, because ultimately it also provides volume, right? And volume underneath the skin will help reduce wrinkles under the skin. So this fat pad transfer that we see as a popular procedure in aesthetic medicine is actually very, very exciting. But the benefit is not actually removing the wrinkles, it's smoothing them out by providing more rigidity underneath them, right? I don't think personally that it is the growth factors that are being released by the small percentage of adult stem cells that would be part of these fat transfers. That being said, there is a visual change, right? You do provide some padding underneath the skin that pushes it up, makes it more voluminous, and that's exactly what we lose with age, right? Our skin wrinkles because we lose elastin in our skin, we lose the collagen, right? And we lose hyaluronic acid that is responsible for retaining the water and some volume. And that collapse, right, of all of these elements ends up leading to wrinkles, right? We just don't have the same elasticity and we don't have the same rigidity underneath them. A lot of that is actually not even the surface, right? It's what's going on underneath. It's losing muscle mass. Sometimes in cases it's losing bone mass, especially around the mouth with dental stuff that goes on as we age. And then on top of that, the layer of cells underneath our keratinocytes, the fibroblasts, they actually shrink, they get smaller, they get lower in volume because the adult stem cells that are responsible for keeping that volume up can't perform as well, and the numbers go down.
Yeah, and as far as like the stem cells that we use for, like, let's say joints and back pain, where are those typically from? Is that from bone marrow typically, or is that also from adipocytes?
Yeah, so I have to say most of this work is going on outside of FDA approvals.
Yeah.
Most of it. Okay,
Yeah.
so with that caveat, some of the groups that are working on this are working in a multitude of areas. I think one of the more most of that work is focusing on mesenchymal stem cells. Mesenchymal stem cells can be derived from multiple areas of the body, right? We have a few different pockets of these cell types. One is in the hair follicle, and another one, we do derive from bone marrow. And these cells can be quite powerful in musculoskeletal conditions because ultimately mesenchymal stem cells either become bone, cartilage, or fat.
Got it. Yeah. So in summary, then, bone marrow, adipocytes, hair follicles, they can all be used for stem cell applications. Currently, bone marrow and adipocytes are being used quite a bit for, whether it's FDA approved or not, for aesthetic reasons, for joint pain, back pain, things like that, right?
Yeah.
Hair follicles are not currently being used yet for applications. However, we have the capability of preserving them for stem cell use in the future. Am I right with that?
Yeah, so they're being used in trials right now.
Yeah.
Right, so you can't walk into a stem cell clinic. Not that I'd necessarily, not knowing which one you're going to, I wouldn't necessarily recommend that anyway. But it really just depends, right? There are groups around the world where in areas that are leveraging skin cells for these therapies. They're taking it through a punch biopsy. So it's more invasive. You suture the wound closed, but you're taking a section of your skin and then using that to try to treat another area of your skin. Recent work, not just by us but by others, has found the power of the cells that are located in this very concentrated hair follicle, right? And so that is now where a lot of the work is going on in their clinical trials, using hair follicle cells to treat things like discoloration of the skin, burn victims, wound healing, right? So non-healing wounds, diabetic foot ulcer, and a number of other conditions. And those trials are underway. So it is being applied in humans, but in clinical trials.
Yeah. I mean, I'm a firm believer that stem cells are going to they're going to be one of the biggest players in functional medicine and age management in the future. I strongly believe that they're going to have a huge part in that. I think what I like about your argument is, with the fact that the older we get, the less viable and effective our stem cells may be. So you need to save them now, basically, right? I mean, they're not going to be any better tomorrow as today. I mean, today's, every day you get older, the less and less effective a stem cell.
Doesn't matter what smoothie you had that morning or how many push-ups you did. Yeah, unfortunately, you are a day older.
Yeah. So tell me about how the Acorn product works then. Who do you sell it to, and how do they extract the stem cells?
Yeah, well, we're excited to be working with some of the top physicians in Canada right now, and very soon in the U.S. So it's just talk about Canada right now. In a number of different clinics, a lot of them in the plastic surgery, dermatology, aesthetic medicine space. You're able to go to their clinic and have your cells collected. We've got a very simple kit, non-invasive, very quick procedure. You can be in and out in 15 minutes, and ultimately you then have your cells plucked from the back of your scalp, cryogenically preserved at our core facility. They get sent to our core facility after collection, and they're preserved in liquid nitrogen for you to have access for the rest of your life too. So we are accessible in the Toronto area, and we're in a few other Canadian cities here very shortly. And you can go to our website to learn a little bit more. So it's acorn.me, and there you'll find an overview of what we do, a little bit more detail than we're talking about now, and ultimately places where you can have this done if you happen to be in Canada, and especially in the Toronto area. We've got many partners. And if you're not, then you can sign up to a request access list so that you will be the first to know and first in line when we launch in the U.S. later this year. And so we've already have a number of physicians that are going to be part of that initial launch in a number of different regions. So we're pretty excited for entering crossing the border.
Yeah, that is exciting. I'm also involved in a medical spa and integrative oncology center. I think that would be something that a lot of my patients would find interesting. So it sounds like we have to wait a little bit though before we come to the U.S.
Not very long.
Yeah, not very long.
not very long. Right now, we're looking at being available this year. So
okay, great.
My suggestion would be, to any listeners that are interested to sign up on that list, so you'll be first in line, and we're coming as quick as we can.
Great. Yeah, and just to make it clear for our listeners, Acorn's product is not for treatment, right? It's really about banking and preserving your stem cell, so that when there are future applications, you are getting it at the, at a younger version of yourself, basically.
Exactly, right. So, we want to be operating within FDA Health Canada guidelines. So the therapies that you'll be using our cells for will be, validated, verified therapies that have gone through any trials. That being said, using the cells to create these products that do not have cells in them, it's a much shorter path. So those things are going to be available much quicker. So I think there will be a very quick utility of those cells in aesthetic medicine for skin regeneration and hair regrowth, skin rejuvenation. So I think that's coming very quickly. But absolutely, this is an opportunity for patients to take out a biologic insurance policy. Right? I saw firsthand that our ability to help a patient later in life was going to be dependent on the quality of cells that we had access to from them. And so most of the time when you're going to end up being in a time of need and you're going to be seeking out these things, it will be later in life. And unfortunately, your cells will be at their worst. So this is an opportunity to make sure that in your time of need, you have the best version of yourself available and accessible to hand to that physician to say, here, help me with my younger self.
Yeah, that's really, I like how you said it's kind of an insurance for yourself, for a later version of yourself. It makes total sense. Thank you, Drew. Thank you for taking the time to come on and educate us on stem cells. I know we like to usually end the session by asking our guests what your guilty pleasure is. So,
yeah. So I don't do it very often, but I do enjoy a cigar.
Okay. Yeah.
Yeah, that's my guilty pleasure. Yeah.
Do you have a favorite brand?
You know what? We're in Canada, so I can get access to some decent Cubans.
Oh, good. Yeah.
So I do like a nice Bahique, if on a nice occasion. But I like Fuente. So Fuente Opus X was a go-to down in the U.S.
Very nice.
Yeah. So there's a few good ones.
Awesome. Well, thank you so much. This was fun. And if someone wants more information or they want to, contact you, what's the best way?
So, shoot me a message. Message is open on Instagram. You can find me there at Dr. Drew Taylor. I'm on Twitter at Drew W. Taylor. Acorn.me is also a great resource, and you can always there's a message sending function to get a message to us.
Awesome. All right.
Okay.
Well, thank you, Drew.
Awesome. Thank you so much. Appreciate it, Bobby. Talk soon.
Okay. Bye-bye.